Welcome. This is the video for 5 a day questions for A-level Mechanics 1, Day 1. Question number 1. A cyclist travels in a straight line A to B. So it is traveling from A to B and with an acceleration of nothing but what? 0.06 meters per second square. The velocity at A is 3 meters per second and velocity at B is 6. Find the time taken. So V equals to U plus 80. 6 equals to 3 plus 0.06 times t. Once I do that one, I am going to get the value of t. How much is the value of t? I get it at 50 seconds. Find the distance AB. So what am I going to use it at? S equals to V square equals to U square plus 2as. That's going to be the easiest formula. V square equals to U square plus 2as. So 6 square equals to 3 square plus 2 times A 0.06 times S. This gives me S value as 225 meters. Now the next a car leaves. Next time it is a car. Leaves at the same distance A. So it is leaving at the same instant at A. Car starts from rest. So initial velocity for car is going to be 0 and it reaches B. So the distance is going to be nothing but what? 225 meters. And the velocity of a car at t seconds is kt square. So velocity equals to kt square. So I want to know the distance means I do the integration of that. So distance equals to kt cube by 3 plus c. Don't forget to write plus c. But we know that when t equals to 0, s equals to 0. So this gives me 0 equal to 0 plus c, c equals to 0. So what is the distance formula? S equals to kt cube by 3. Plug in the distance, 225 equals to k times 50 cube by 3. This gives me the k value as 0.0054. What is being asked? Find the speed of the car at B. So V equals to, so I want it out V equals to U plus 80. So I don't use that one. So I'll be using it out V square equals to U square plus 2as. U square plus 2as. Instead of that also, the best one we know that it is the V is kt square. V equals to kt square. K is nothing but 0.0054 and total time at B will be 50 seconds. So at the same instant it reaches. So 50 square, which is going to be 13.5 meters per second. Coming to the second question, the diagram shows the velocity time graph of two cyclists P and Q who travel in the same direction. Both cyclists start from rest and the same point rho. Both accelerate at 2 and reaches 10. Then they continue at a constant speed 10. Show in the sketch the diagram the region whose area represents the displacement of P from O when Q has started. So Q has started at T, so this is going to be the displacement. Given that P has traveled a distance of 16 meters. So S equals to UT plus half AT square. So 16 equals to 0 times T plus half A is 2 times T square. T square equals to 16. So T equals to 4 seconds. So this is going to be 4. Then the distance between P and Q when Q reaches a speed of 10 meters per second. So for Q, initial velocity is 0, final velocity is 10, acceleration equals to 2, T equals to question mark. So again, 10 equals to 0 plus 2 times T. So this T equals to 5 seconds. So 5 seconds from here means it will be 9 seconds. 5 plus 4, 9 seconds. Now what is the displacement? So what am I going to do? I am going to find it out area of this trapezium for P. Area of this trapezium. So we know this is 10 and this distance is 9 and this distance is 5. What is this? Why it is 4? Because we know that P also will take 5 seconds. So this is 5 because when Q has taken 5 seconds, P also will take 5 seconds. So this distance is going to be nothing but what? 4. So area, the distance is distance traveled by P. Distance by P will be area of a trapezium half times 9 plus 4 times 10, which is going to be nothing but how much? I am going to make it as the distance, which is 13 times 5 65. 13 times 5, 65, minus, I am going to subtract the area of this triangle, minus area of the triangle. So 65 minus area of a triangle. Area of the triangle is half times base is 5, height is 10, which is nothing but what? 65 minus 25, which is going to be 40 meters. That's going to be the distance traveled by distance between P and Q when Q reaches a speed of 10 meters per second. So I take the area of trapezium minus area of triangle. Area of the trapezium minus area of the triangle will be the distance between P and Q. Now coming to question number 3. So in this question number 3, a boy runs from a point A to C. He pauses at C and then walks backwards towards A until reaching the point B. He pauses at C and then walks backwards towards A until reaching a point B where he stops. The diagram shows a graph of v and t, where v meters per second is the boy's velocity at time t seconds after leaving A. The boy runs and walks in the same straight line throughout. Find the distances between AC and AB. AC and AB, he is asking us to find the distance. Now, A to C. So first of all, he runs from point A to C and then walks backwards towards A. He pauses at C. So this is A to C is this part. This is AC because he's running and pausing. So that's going to be the AC 10 times 7, which is going to be nothing but what? 70 meters. That's going to be the distance area. Now he's pausing at C and walk backwards A until reaching a point B. Now he is walking backwards. This distance is backwards. And what is the area? Backward, how much he is walking? That area is going to be 15 times 4, which is going to be 60. So 60 meters. So he went forward 70 meters and he came backward 60 meters. So from A to C he went 70 meters and C to B he came back 60 meters. So what's going to be the AB's distance, which is going to be 70 minus 60, 10 meters, which is the distance between A to B. Sketch the graph of x against t, where x is the meters of boy's displacement from A. Show clear the values of t and x when boy arrives at C and when leaves at C and when he arrives at B. So we are going to draw a displacement time graph for this. So once, what is he doing it out? He's starting from 0 and going to a distance of 70. This is 70. Then he pauses for a bit. Then again he comes back only till 60. So this distance is going to be 10. Now we need to write the times also. This is time in seconds and this is the displacement or x in meters. Now 0 to 10, he took how many seconds to go? 10 seconds. So this is 10 seconds. Then 10 to 15, he is waiting. So this is going to be 15 and then 15 to 30, he is coming backwards. So this distance is going to be 30. So this is going to be the way how it is going to be drawn. Now coming to question number 4. The particle P1 is projected vertically upwards from a horizontal ground with a speed of 30 meters per second. It is being projected vertically upwards with a speed of 30 meters per second, and at the same instant another particle P2 is being projected vertically upwards from the top of a tower of a height 25 meters with a speed of 10 meters per second. Find the time for which P1 is higher than the top of the tower, the velocities of the particles at the same height, the time for which P1 is higher than P2 and is moving upwards. So a bit complicated question, see carefully. A particle P1 is projected vertically upwards from horizontal ground with a speed of, so this is horizontal ground, this is P1 and it is being projected with a speed of 30 meters per second. At the same instant, another particle P2 is projected vertically upwards from the top of a tower of a height 25 meters. So there is a tower of height 25 meters. This height is going to be 25 meters. From here, we are projecting P2 with a speed of how much? 10 meters per second. Find the time for which P1 is higher than the top of the tower. P1 is higher than the top of the tower. The time for which. So, what is that? When it will reach 25 meters, we are going to find out when does P1 reaches 25 meters. So, S is equal to UT plus half AT square. So, 25 equals to 30t minus, because it is going up, minus half, g is 10t square. So I get it a quadratic equation, 25 equals to 30t minus 5t square. Then simplify it further, divide by 5. So you'll be getting t square minus 6t plus 5 equals to 0. So you factorize it out, t minus 1 times t minus 5 equals to 0, t equals to 1 second, t equals to 5 seconds. Basically what is happening is when I throw this one up, it goes up like this and comes down. So at what point it is at a height of 25 meters? At 1 second and 5 seconds. So the time for which is P1 is higher than. So it will be higher than. So what am I going to do? It will be higher than 25 meters for time equals to 5 minus 1, which is going to be 4 seconds. That's going to be the answer. The velocities of the particle at the instant when the particles are at the same height. They are at the same height. So S1 equals to nothing but what? 30t minus 1 upon 2, 1 upon 10 t square. So which is S1 equals to 30t minus 5t square. Whereas S2 is equals to 10t minus 1 upon 2, 10t square. So S2 is going to be nothing but what? 10t minus 5t square. Now both S1 should be equals to S2. Then that is the distance. So but S1 should, what is that S1? S1 is nothing but what? S2 plus 25. So or S1 minus S2. S1 minus S2 should be equals to 25. Because whatever the distance S1 is traveling, it has to travel the 25 meters plus the distance traveled by S2. So therefore S1 equals to 25 plus S2. So S1 is nothing but what? 30t minus 5t square equals to 25 plus 10t minus 5t square. We can see that 5t square gets cancels, which gives me 20t equals to 25, t equals to 1.25 seconds. So at 1.25 seconds, they will travel the same distance. So V1 equals to nothing but what? 30 plus minus 10 times 1.25. This is for the first particle, which is going to be nothing but how much? 17.5 meters per second. Whereas V2 will be nothing but what? 10 plus minus 10 times 1.25, which is going to be nothing but what? Minus 2.5 meters per second. Means it is coming downwards. Those are going to be the velocities. The time for which P1 is higher than P2. We want to know P1 is higher. Throw it out, what is that? We are throwing it out P1 with a speed of 30 meters per second from the ground and from a height of 25 meters above. 25 meters above, P2 has been thrown. P2 has been thrown with a speed of 10 meters per second. Now what is happening is P1 goes like this and comes down, whereas P2 may go it out and come over here. Now in the first part we have just now in this part we have found it out at 1.25 seconds. They are at the same height and V1 was going upwards and V2 was coming downwards. So maybe they are at the same height. Over here at t equals to 1.25 seconds, P was going up and P2 was coming down. So for the remaining time, for this remaining time, P1 will be for this remaining time. For this remaining time, P1 will continue to go upwards. So what am I going to find it out? I am going to find it out the time of ascent for P1. Time of ascent for P1 is nothing but what? U by G, which is 30 divided by 10, which is 3 seconds. 3 seconds, then 3 seconds minus 1.25 seconds, which is going to be 1.75 seconds. So for 1.75 seconds, P1 is going upwards, P1 going upwards, and P2 coming downwards. That's going to be the answer. And last question for this day 1, it is been asked that the diagram shows the velocity time graph of a lift moving between floors in a building. The graph consists in a straight line segments. In the first stage, the lift travels downwards from ground floor for 5 seconds, coming to rest at the basement, traveling a distance of 10 meters. So this distance is going to be 10 meters. So area of the triangle, half times base is nothing but what? 5, and height is going to be the V maximum equals to nothing but how much? 10. So this is going to be V maximum is going to be giving me, what is this? 4 meters per second. That is for part 1. The second stage consists of a wait for 10 seconds at the basement. It is waiting for 10 seconds at the basement. In the third stage, the lift travels upwards until it comes to a rest at a floor at 34.5 meters above the basement. Above the basement, arriving at 24.5 after the start of the first stage. The lift accelerates with 2 meters per second squared for the first 3 seconds of the third stage and reaching a speed of v meters per second. Find the value of v. So in the first 3 seconds, it is going at a speed of 2 meters per second. So v equals to question mark, u equals to 0, acceleration equals to 2, time equals to 3. So we know that v equals to u plus at, so which is going to be 0 plus 2 times 3, which is going to be 6 meters per second. So what is the value of v? V is 6 meters per second. Then it comes to a rest at a distance of 34.5. So the total distance is going to be nothing but what? 34.5. And what is he asking? The time during the third stage for which the lift is moving with a constant speed. So we are going to find it out. This is the constant speed. So this distance is going to be nothing but what? 9.5. And this distance is, let it be, time t. And this height is going to be 6. And he's telling that it is traveling a distance of 34.5. So the area of the trapezium, 34.5 equals to 1 upon 2 times t plus 9.5 times 6. This should be giving me this answer. So t plus 9.5 equals to 34.5 divided by 3, which is 11.5. T plus 9.5 equals to 11.5. So t equals to 2 seconds. So for 2 seconds, it is traveling at a constant speed. The deceleration of the lift in the final part of the stage. What is going to be the deceleration? He is asking us to find it out in the final part of the stage. So this velocity was 6 and this velocity was 0 over here. For the final part, initial velocity is going to be 6 and final velocity is going to be 0, and time equals to how much? So it was 2 seconds. So this one was 18. 18 plus 2 seconds, 20 seconds. So this one will be nothing but what? 20. So the remaining time is going to be nothing but what? 4.5 seconds. Time equals to 24.5 minus 20, which is 4.5 seconds. So we know that v equals to u plus 80. 0 equals to 6 plus a times 4.5. So a equals to negative 6 divided by 4.5. So which is 4 upon 3, negative 4 upon 3 meter per second square. So but is asking deceleration. So deceleration is going to be 4 upon 3 meter per second square. That's going to be the answer. So that completes the video for day 1 with 5 questions. See you in the next video. Bye.